Oh, my microphone's muted. That'll do it. Okay, so um, today we're looking at concept around test scheduling. So a lot of the times in RX programming, you'll have to send in what is considered an iScheduler. So this interface right here. This interface, let me pin some stuff because otherwise I'll lose it in the tab proliferation. Um, Let me bump this just to make sure that the font is big enough for all those who decide to watch. A little bit bigger. Okay, so you'll see that this iScheduler has a schedule. It has a date-time offset of now. It's got some other methods around scheduling, and it returns a disposable. So this is a fairly complex concept, and you'll also notice that it's in the system.reactive.concurrency namespace. So this is a very more or less delicate problem because like concurrency is hard, and the way that .NET does concurrency with TPL is by building a state machine to handle your concurrency for you. So it knows where it left off and the state machine comes back, yada, 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 a whole bunch of stuff. So it knows what context to go from and to. In the RX world, I can explicitly say, hey, go to this context and go do the thing from this context. And there's no issue there. So, um, gonna kind of get into really like unit testing this today to give folks an understanding of how this stuff kind of works. I've got a class that I've already built that's going to take in an iScheduler, which means this is the scheduler that this class is going to execute its stuff on, right? And you can do fun stuff like register an iScheduler to your IOC container. I would tell you, well, let me first, I wouldn't tell you. I would ask you why, and I would also I would caution against it. Um, Scheduling is a very very complex thing. Like writing a scheduler is hard. I've looked at what it takes to write a scheduler. I've not even written one myself, and I was just like, that's more than I care to chew off. But like scheduling is hard. Writing a scheduler is hard. So there are schedulers that are already written, and you probably just want to use one of those. Um, in reactive UI, we explicitly give you some that are facaded out, or technically they're bridged out, but they're platform specific behind a platform agnostic concept of this iScheduler. So we kind of provide you one per platform. And we do that statically through the RX app. There's nothing preventing you from registering this to your IOC container, but I'm going to tell you right now, like you can't, it's going to get weird, right? Because you're going to have an iScheduler and then you're going to have an iScheduler and it's like, okay, well, which one's the main thread? Which one's the task pool? So then you're going to register a named scheduler, which then you have to determine whether or not you want a new scheduler every time or if you want the same scheduler. So then if you get a new scheduler every time, right, like you do it transient, you register it transient, then you'll end up with potentially a new scheduler every time, which could cause like a lot of problems if you're expecting it to be on the same concurrent scheduler, right? And if you register it as a singleton, there's really no difference than what you already have in RX, which is the RX app dot main thread scheduler. So generally, because you would end up passing around that scheduler in pretty much every single view model that you have, and that, or potentially, not every single one, but potentially you would end up injecting that, and that would become a hassle. And then you have to mock that out, right? So then you've got to mock that out for every single test. Right? So now you've got to explicitly mock that out and make sure that that scheduler is not clouding the implementation details of your test. Um, sure, go ahead if you want to. I'm just going to stand on the backs of giants and use stuff that's already available to me because writing schedulers is hard. And the concept of having to grab the right one at the right point in the life cycle out of an IOC container is cumbersome to me. And I'm a type of person, I don't really like statics. Like statics are not my favorite, but in that instance, like statics make sense. Anyway, so we take in this scheduler, right? And behind the scenes, there's just this base class, which is just a reactive object. So I'm using the base extension point of reactive object. I'm making sure that this thing is disposable. I'm providing a subject for any downstream inheritor of this concept to do the running. I'm holding onto the scheduler, which I'm taking in from the constructor. And then I've got a composite disposable that tells you when the time's up. So when the time's up, I'm going to allow you to dispose of the thing, right? Yeah, so we dispose of all the stuff. I just got done telling somebody earlier this week that this is probably a better way to do the things. So we're going to do that first. So we're going to do question mark dot on completed and then dispose of it. Yeah. You know what? We're just going to do this because we can be smarter than this. Because we can do running new subject dot dispose with time's up. So then this by default would be like a transient thing that we would have to new up every time, right? Because we would want a new timer every time we go to the container to get a timer. Because one timer will be stateful for the state of the single timer. Once it's disposed, then we'll get rid of all of this stuff. Okay. Yeah, so then all we have to do is do on completed and then time's up. So then we don't have to worry about that. We can get rid of this thing because that becomes overkill. Remove it. Yay. Okay. So, all right, we've got our timer object. We've got this is running property that we can bind out to the view. We've got this timer method, which takes in a start time, tells you whether or not it can start immediately. We are hardwiring a refresh interval. We probably want to do this slightly differently, or maybe allow you as the consumer to pass in the refresh interval. That's an option, I think. We've got this thing to determine whether or not it's running. It's going to start with starts immediately, right? So start immediately, it's going to go and do its thing, and it's going to start checking on running. It's going to take a running, and it's going to property it out to is running. I'm actually going to change up some of this code as we go. So it's funny, you write code, then you come back and look at it later, and you're like, oh, well, why didn't do I need this? I don't need it, perfect. Then you come back later, and you're like, why did I write this way? Like, who wrote this horrible code? Oh, wait, I did it. How many times I've done that? All right, so we're taking the subject, we're making it an observable, which begs the question, do we just want that to, no, because I think we actually explicitly have to on next it here, but maybe in our actual implementation of this, we'll think about that next time. Hopefully we'll remember this conversation with ourselves. And if we don't, then oh well. So we're going to set the resume time to the start time here, okay? And then we're going to go ahead and create our timer. So we're creating a time span, or we're creating an observer of time span. We're doing an observable.interval. We're doing on the refresh interval that we take, which is 1,000 milliseconds. We're taking in the scheduler that we've passed in. So this is where the crux of it comes in, right? We're explicitly telling RX to run this interval on this scheduler, which means at some point we are going to have to go back out to another thread. Oh, I guess that's why we needed is running, or we needed that running thing. Boo. Okay, we'll go back and undo all the bad code, and then we'll still come back here and do this. Start to .to property .dispose with out is running. Okay. So is running. All right. So return. Okay, so we're going to return whether or not this thing is running. Oh, no, this needs to not be that. That needs to be this. It's going to be running.toProperty. So that way we're not reusing all that. All right. All right. Maybe we can do that somewhere in the constructor and make that not be so bad. But all right, so the timer function is going to start depending upon that. So here we've got our observable.interval where we're doing a refresh interval. We're doing a scheduler. So this is the scheduler that we're passing it on. So at some point, this thing is going to have to let itself be known that it needs to run on another or return to another thread. But that's a downstream problem, not an upstream problem. So I'm not going to worry about that right now. Because wherever we subscribe to this timer is where we're going to end up having to do that. So maybe we would do that here. We would do a observe on. So the other good thing about this static thing that we have here is like this is already ready for unit testing. So it knows underneath the hood whether or not it's in a unit testing context. And when it is in a unit testing context, it goes ahead and just gives you the immediate scheduler, which is, again, if you don't know about schedulers and you get to start playing with schedulers, like you may bite yourself in the foot. I've done it. I know others who have. Scheduling is a tricky concept because we're dealing with thread contexts, and anytime you're dealing with thread contexts, you end up having the ability to potentially create memory leaks or leaving things in the wrong place or hard crashes in your application. All right, so this is where we're creating the actual observable for the timer. We're doing it here. All right, okay, so we're doing that explicitly so that we can dispose of it with the time's up. This is just stuff I'm playing with to see if I like doing it better to use the dispose with, or if explicitly doing the return disposable from observable.create. But anyway, so we're returning, we're running, we're doing a select. So if it's running, we're going to return the timer. If it's not running, then we're going to return time span. We're going to switch so that we're always subscribed to the correct one. Coming out of this select statement, then we'll do a publish ref count so that every downstream subscriber gets the same thing. So everybody's getting the same timer when we start the timer. All right. So like things that we're going to want to look at, right? Because this is a decremental timer, right? We are doing a scan, we are doing an accumulation, and the accumulation is subtracting the overall time span from the refresh interval from the overall time span. So this thing's going to take until it's greater than or equal to 0. I feel like I've ran into some really awkward case where like subscribing on fixes something that this thing doesn't pay attention to, but who knows? We'll figure it out along the way, I think. So like there's a couple of unit tests that we can write, but like let's start off with like simple stuff like, it should start when we actually started as opposed to like whenever it wants to, right? So the tool chain I'll be using tonight is xunit and substitute. Oh, did I bring in n substitute? I don't think I did. Let's go do that real quick. Yeah, xunit and substitute Microsoft.reactive.testing. I'm going to bring in reactive UI.testing so I can use some of that stuff. Package reference include reactive UI dot testing. Version is going to equal whatever version we brought in for everything else. We did say in substitute. I think it's raining outside. Can't hear with these things on my head. And substitute version is going to equal 4.2.2. So if you're wondering what this is Rider's ability to do like CS project files. And if you were around in like the DNU DNX days of .NET, you'll remember that at one point project JSON files were acting like this. Like you could actually just type in the project JSON file and get IntelliSense and understand what versions were available. Um, well, Rider gives you the ability to do that. I don't know if Visual Studio does or not because I candidly haven't used Visual Studio on more days than I care to count. But I know Rider gives you that ability, so you can come in here and just add a package reference from the XML and get full fidelity into what versions are available. Fluent assertions, all that seems good for the moment until I figure out that I need more. So yep, no, that's definitely Thunder. So let's go ahead and get to the tests, right? So we're gonna do rename the file to match the type. All right, so we'll that the timer should start when started. All right. So given we have some var test schedulers, this is where like all the magic comes in, right? In like test scheduling. Scheduling is like really hard. If you go look at the docs, like the docs are really unclear on a lot of parts, which makes it, I guess, in my mind, even harder to deal with. But again, that's neither here nor there. We'll have a decrement timer. Timer. Oh, hey Rodney, why doesn't that thing work? Maybe because you should add a package reference or a reference to the project. This is gonna be our system under test. It's gonna equal new decrement timer, and we're gonna have to pass in this test scheduler. So we're actually gonna take the moment here and show another thing that I have come to enjoy. Internal class decrement timer fixture. And we're going to do a public static implicit operator decrement timer of decrement timer fixture. We're going to have a fixture, and then we'll have our fixture return a build. I think if we're smarter than a fifth grader, this should already be here, and it is. All right, great. So we'll create this build method, and we will do a new decrement timer with underscore scheduler. Create field scheduler. This is going to equal substitute dot for scheduler. 1 second. Sorry about that. Yeah, that could be private or read only. Not can't be read only. So then we're gonna do a public with scheduler, scheduler, and start with ref underscore scheduler with the value. Oh no, with the scheduler itself, huh? There we go. Okay, so we're just gonna create ourselves a quick fixture so that we can do this a little bit easier. So that way we're not doing that up there. We're doing this. So we'll do this dot with scheduler, test scheduler. All right, so that'll new up our test scheduler. So ooh. Oh, okay. Yeah, we actually want to do, so we want to have our timer to equal time span dot 0. Oh, it started raining pretty good outside. I don't know if you guys can hear it on my microphone, but I can't. So system under test dot timer time span from seconds. From seconds 3, and we will explicitly say that we don't want it to start immediately, right? So I guess the better thing is it should, instead of should start when started, should not start immediately. Subscribe x timer equals x. Boom. Now I've got a subscription. I'm actually going to put a breakpoint there because I know I'm going to want to pay attention to that. And then, home. Then, oh wait, we have more stuff in our when clause, don't we? This should actually be in our setup. Now that I think about it, that needs to be in the setup. All right. And then here we'll do test scheduler dot advance by milliseconds, and we'll do 2000 milliseconds, and we'll verify at that point, right, that the timer should be time span of 0. So this is important, and we're going to talk about that in a second, right? Because what I'm saying here is, okay, I'm giving it a scheduler, and we already determined, because this thing inherits from iScheduler. Oh, goodness. There we go. Let's just grab that. iScheduler. Boom. So iScheduler has a datetime.now. So the scheduler actually, or datetime offset.now. So it's basically giving you a timer that's kind of agnostic to everything. And that's kind of how it works and how it deals with stuff. So because it knows what time it is, it's going to understand concepts of time. So we can advance by 2,000 milliseconds, which will show that the scheduler, the clock that this construct is running on, right? This clock that this construct is running on is moving, right? But even though the scheduler is moving, doesn't mean that this timer is actually doing anything just yet. All right, so we're going to prove that we can advance it by 2,000 milliseconds, and then it should still be 0, right? Because it shouldn't have already started. And then we're actually going to go ahead and subscribe to the timer, right? So then we're going to say system under test dot start, right? And that's going to give us the actual start, the ability to actually start the timer. Then we're going to go ahead and say test, or wait, we're going to take the test scheduler again, and we're then going to go ahead and advance it by we're going to advance it by 3,001 milliseconds. Now, this is very important. When I first started testing with this, I would do this, and I'd be like, why didn't my thing move? Well, there's like a less than, greater than, equal to concept baked into this. So if you don't actually tick past the value that you're expecting, you actually won't get the tick. So that's a very interesting concept that I did not understand when I first started testing these things. And then, but you know what, we're actually going to do this here. We're going to 2001. We're going to veer from the thought process for a second. Should time span from seconds 1, right? So that should be true when we finish this. Okay. All right. So let's fire this thing up. Let's go ahead and get started. So first things first, we're going to just run it and see if we green light, because we should green light. Yeah, we should green light. But to prove that we actually will get a red light, right, we'll set that to 1. We'll advance by 1 second, and this shouldn't be 1 second now. This should be something else. So just to prove that we get a red light. Yeah, there we go. So our test says expected 1 second, but found 2 seconds. So let's walk through the thing, right? What we're doing is we're giving the system under test the test scheduler, and then we're explicitly advancing by a certain number of milliseconds. So let's stop here and say that, you know what, this is actually, well, this is a good test to start talking about it, but this is probably not a good test, just for the sake of looking at the overall thing. How do I explain this? This is hard to explain without having somebody asking questions, because like I know enough about this to be dangerous, but not enough to be able to explain all of the intricacies around it. So I'm going to do my best to explain it as best I can. So this is taking an iScheduler. That iScheduler is our test scheduler, right? Then we're going to, we might even be able to dig into the actual test scheduler doing the thing, right? But we're going to advance the test scheduler by 2,000 seconds, which means in our instance, because we are using this timer concept and we're using that interval and setting the refresh interval to 1 second, right? Because we're doing that, it's going to tick every second. Fair? Okay. So we're green. Hopefully we're green there, right? Everybody's following me so far and not going to call me a liar, which... Okay, so I'm actually going to take this headset thingy off for a little while and listen to the rain behind me. Let's figure this out. Okay, all right, so where we are. Okay, we're talking about the decrement timer. We talked about how this test scheduler is getting injected. The test is going to advance by 2,000 milliseconds, which means our timer should still be 0, right? Because, and I'm going to start putting, I'm going to start putting breakpoints in here in a second. Because if we're not running, we're going to return an observable.never of time span, right? Which means we're always going to get back, we should always get back that 0 condition. So we're going to put a breakpoint there, and we're going to walk through this in a second, right? So every single time the timer ticks, we should hit the scan method. So the scan is an accumulator operator. There we go. Let's go to Rodney's favorite website for RX operator. RX reactivex.io/operators. Yep, okay. And then we will go to looking for accumulation. Maybe they're not called accumulation functions. What are they called here? Conditional, mathematical. Nope. Back pressure. Nope. Replay, connectable observable operators. I didn't realize replay was a connectable observable operator. That's good to know. I guess that's, yeah, it would have to do that, right? It would have to create a connectable observable to be able to do the replay on. Operators, yeah. Let's find scan on that list. Okay, so they call them transforming. flat map. I think flat map is select many, but whatever. Okay, so the scan apply a function to each item emitted by an observable sequentially and emit each successive value. Yeah, so it's an aggregator of sorts. So what we're gonna do is take whatever the overall value is and subtract the refresh interval timer. We're going to take it until the time span is greater than or equal to time span from 0 seconds, because this is this is important. Interesting thing. I won't call it important. So you had this take until time span from seconds 0. So this is the difference. So anyone who's ever seen, what's the movie? Now I'm blanking on the movie. Lethal Weapon. Anyone who's ever seen Lethal Weapon will know, like, is it 1, 2, 3 go, or do we go on 3, right? Like, so this take until right here is going to be where you define go on 3 or 1, 2, 3 go, right? Like so is it 1, 2, 3 go, or is it 1, 2, 3, or is it 1, 2 go, or is it 1, 2, 3 go, right? Like, is it go on 3, or anyway? So that's what this is. So you'll find weird stuff if you do that with scheduling on different threads because we're dealing with time. We are explicitly doing a do statement, which I don't like do statements, but I understand why I'm doing this do statement now. In my do statement, I can deal with my on next and my on completed. So when I complete, I'm setting the start time to the resume time. On next, I'm setting the resume time equal to whatever the time is that we started at, right? So that's the reason why I'm using do here. RX Wizard explained that one to me. I didn't want to use do, but it's the right thing to do. See what I did there? Anyway, and then we're just going to subscribe to it. So whatever the outside observer is going to subscribe at this point. We're going to dispose it when the time's up. So let's like debug through this a little bit and see what's going on. All right, so first thing we'll notice, oh yeah, of course, it's query language, create, dispose with. It's not running, which means we'll get this time span, or this observable never, which means it'll basically just, I want to say, what does observable never do? Let's go look at it. Rodney prefers to just dig in and look at the, what? Oh, it gave me parallel stacks. I don't want that right now. I am messaging people during my live stream. How rude am I? Or more like people are messaging me. How rude are they? Ugh. Anyway, so the observable.never. Oh, that's why, because when I click on it, it's in proc, so it doesn't know how to do the thing. So we'll just go to declaration. Yeah, key promoter. I can't use it because it's in the middle of executing. I want to know what this thing does. I'm assuming it just returns like, what? All right, now Rodney's got to go look and see what observable never. Empty, right? Because there's empty, there's never, and there's throw, right? So empty, creating an observable that emits no items but terminates normally. Create an observable that emits no items and does not terminate. Okay. Good. Now I get it. So now I remember why we did this. What observable.never does it will forever just continue to return the default value of time span. So now, I guess I probably should have put breakpoints in the unit test, huh? Let's be smart and go do that. Let's get rid of that because we don't need it. Key promoter X, you're getting on my nerves. Let's go back to the unit test, and let's put breakpoints every time that we're going to advance. Every time we advance the scheduler. And when we set it. All right, so let's go back and debug. All right, so it's running as false, right? So we're going to take the test scheduler in advance. we'll notice that when we take that test scheduler in advance, nothing happens. Like we don't get to go back to our other method, right? Then we're going to verify that the timer hasn't been changed, because it hasn't, right? It hasn't gone into that breakpoint. Okay, great. Now we're actually going to do system_test.start, which is going to start our timer, right? So now when we start our timer, notice that the value of running just ticked here. So because the value of running ticked, now we get running true, so it's going to start returning our timer. Go back, right? So now it's actually going to start returning values on our timer. So now we're going to advance by 1001 milliseconds, so just over literally just over a second, and we will hit F5. You'll notice that now the observable interval has ticked because we advanced by 1000 milliseconds. So the refresh interval is 1 second. Yep. The start time of the thing is 3 seconds, which is what we initially started with, right? The accumulation, conjunction, junction, what's your function? The accumulator function is ticking. It has the full 3 seconds. It's taking the 1 second off, right? Okay, accumulator. Do your thing, do your magic. We're going to set the timer equal to X, which is coming off, which is the time remaining from the decrement. And we'll notice again that they're inconsistent. This becomes pretty powerful, right? Because like now we can test that our timer actually does what it's supposed to do. So like if we kick it back up to advance by 2001 seconds, we're now going to see this cycle happen twice. So we're actually going to take that breakpoint off. We're going to see this cycle happen twice. We don't care about the initial advance by. We proved the fact that it doesn't start until we actually tell it to start. And we did that by sending in the test scheduler and and explicitly taking control over the test scheduler or the scheduler implementation. All right. So are we debugging? Are we not? We're not debugging. Debug. All right, so you'll see that we are not running, so we're actually going to go ahead and just put a breakpoint and say is running. Yeah, we just do is running. Ha! Because it's a Boolean. We don't even have to check for the truth value. Ooh. Yeah, okay, done. We just put it in there. Yes, that should work. So we'll go ahead, is running equals true. Off we go. We're going to advance by 2001 milliseconds. So now we'll notice that the refresh interval gets hit, the timer gets set the first time, the refresh interval gets set again because we are literally ticking 1,000 or I think we're ticking in 1,000 millisecond increments. Don't quote me on that. I don't know the implementation details of the test scheduler, but that would be my guess is that's what we're doing. The accumulation happens, timer gets set, and now, oh yeah. Oh yeah, derp. There should only be 1 second left if I've advanced for 2 seconds and I started at 3 seconds. So this becomes fun, right? Because the other thing I'm going to point out, and I'm going to make this into a theory real quick, and then I'm going to pass in some inline data real fast, and I'm going to say we want 3 seconds, we want 10 seconds, we want 30 seconds, and we want 60 seconds, right? And we'll do, oh, can we do this without breaking the world? I think we can. I think I can. I think I can. Yeah, we just have to modify the test. Okay, let's do that. So we'll do int seconds, right? So now the seconds will be what we pass in here. That's cool, right? So this is the other advantage of the test scheduler, right? Like because I know what you're saying. Oh, well, I can do all that, and okay, that's great, right? I can do a task dots. I can just move tasks around and do task dot sleep or thread dot sleep. Oh, okay. Let's talk about that in a second, and why that's like pretty much bad. We're going to set at the beginning of the test var, and we may even go back and change this later, right? Advance by. No, we're going to do it right now. Why not? All right, so we got that, and then we'll do int advance by. Right, that's going to be our advance by is that, and this is going to be advance by plus 1. So that should get us 2,000 plus 1, right? So that'll always get us to go past where we want to go. And then because that makes this math wonky, right? So the time span should be time span from milliseconds, whatever the seconds times 1,000 math is hard minus advance by. Oh, because of PEMDAS, I don't actually need that. .NET is telling me that it's smart enough to know that I don't know how to do math. Good, .NET. I'm glad you know. And knowing is half the battle. G.I. Joe. Anyway, so now we're gonna run all of these tests and hope and pray that Rodney got it right. Actually, you know what? We're gonna run through and debug one just to make sure. Because why wouldn't we want to check to make sure we didn't break everything? Oh, running equals true. Yay. So we're going to, the advanced by is 2,000. Oh, it's going to run through this several times. So let's take all that off. Let's check that the seconds are 60 times that advanced by 2,000. So it looks like our math. What are you doing? Oh, because it's running through everything. Let's stop this. So it looks like our math is correct, right? So now I'm going to point out the important part of this, right? The important part of this is, I'm going to expand that in a second. My mother. How long did it take to run all four of those tests? 214 milliseconds, right? So you see that there that says 214 milliseconds. But we checked for 3 seconds and 10 seconds and 60 seconds, and it didn't take 3 seconds and 10 seconds and 60 seconds for these tests to execute. How is that humanly possible? Welcome to the power of the test scheduler. Again, I don't know the implementation details, but this thing, like if RX is magic, this is like, I don't know, like the one of the most powerful spells in a RX wizard's arsenal, because like you'll notice we literally just ran tests that have time complexity for seconds at a time that ran in milliseconds. So that test that you have to write, that you have to do task.delay Every single time you write that task.delay, it takes longer to execute your unit tests. Pardon me, I've got something in my eye. It takes longer for you to write for you to execute those unit tests. It takes explicitly just as much longer as the time that you are stating it takes. So if you're doing a task.delay for 100 milliseconds, every single test execution is now going to take an extra 100 milliseconds. For every test suite execution is going to take an extra 100 milliseconds. And if you have that times, if you have it that task.delay in more than one test, now you are increasing exponentially for every single test you write. In my mind, it's better to just go on ahead and use this test scheduler and test some good old-fashioned observables. All four, like it's not just one test, but like I want to point out 4 whole tests ran in 200 milliseconds, and we explicitly were testing for 60 seconds worth of time that had elapsed. How is that possible? Again, it's the power of the test scheduler. There's a lot more to the test scheduler it is far beyond what I am capable of talking about. When I first started using the test scheduler, I ran into a whole bunch of issues. I ran into a whole bunch of issues around. Oh, there we go. We should probably make that more visible. We'll figure that out another day. When I first started using the test scheduler, like there was like all of this, you have to subscribe and you have to start it and you have to do all these things. And I'm like, it really kind of threw me for a loop. And then I found this way of doing things and was like, okay, this makes sense to me. But you'll see that you can start like a test with a test scheduler. And that syntax always breaks my brain. But the scheduler has an internal clock and it knows how to do things. So the important part of this test scheduler is it allows us to test all manner of things in a quick amount, right? Like, so we're testing that this thing is going to tick until it's started, right? So like, let's see if we can resume where we actually paused, right? Because we have this case in here where we are pausing our timer, right? We have the ability to pause our timer, right? That pause of the timer will tick the running on next false and we'll start returning this. And then we want to test that when this thing is completed, right? The last thing, ooh, it won't let me get to that one. Oh no. Okay. Let's see if that lets me get to it. You're not gonna let me get to it. Ah, it is. Haha. Okay, good. I'm about to bring that one up to the writer team. That should work. That should have just let me pick. Anyway, I explicitly want to see it reset the start time to wherever we are when we finish, right? To the start of everything. So this will restart it. Like when this thing finishes, it'll set the start time or the resume time back to the start time, but this will actually change the resume time every single tick. So we can start the timer, pause it, and advance the scheduler to see if values are coming down the stream, right? No values will come down the stream just because the scheduler is firing. Then when it's ready, it'll pick back up and start firing on that scheduler again. So let's go ahead and see if we can code that up real quick. And again, I apologize. I am not the test scheduling guru, as it were. I'm just the guy that had to figure out how to use this thing to test stuff. All right, so we've got this fact, I guess we'll give it, and we'll do a void should resume where it paused, right? Because we want to resume the timer exactly where it paused. So we're just going to scrape the above some of this. And actually, we probably want that too. Is that real? Like we want that for every... I guess we probably would want that given for every single test, right? So here we go. Given. How about this? Copy pasta, as a friend of mine would say. Bam. We'll change that to 30 seconds just so that we have a good breadth of time to deal with. Timer, scheduler stuff. All right, so given when... when the test scheduler will advance by 2001 milliseconds. Oh, yeah, we're going to start the thing immediately this time. So now we're going to start it immediately, so you'll see the thing start ticking immediately because we don't care about all that. And then, so we'll advance by 2001 milliseconds, and then we'll assert that this timer should be time span from seconds 28, right? So we advanced by 2001 milliseconds. That means that the timer should have ticked twice, right? Then we're going to do an explicit pause on our timer. Subscribe. So we're going to pause our timer, and we're going to then advance our test scheduler again. So I'm going to point out something else. Because we've already hit the over threshold and we're using advance by as opposed to advance to, because there's another extension method here that gives you there's advance by and advance to. I'm using advance by, which means advance by the amount that I tell you to. Advance to lets you go to a specific place in the timer. But because I've already gone past the second threshold, I don't have to continuously go past that second threshold. I've already done it once, so I don't need to do it again. You can do it, but you'll start to run into weird errors. If you may run into a weird case where you accidentally tick your timer too many times because you didn't realize that you only have to go over the zero threshold one time during the test execution cycle. And I can show you that here in a second, because I think the test scheduler has a clock on it that we can actually look at. So we'll go ahead and do that in a minute. All right, so we'll advance by, and then we'll say that this should, so we'll explicitly advance the scheduler, right? So the scheduler keeps going, i.e. things are happening, but we aren't getting any notifications because we've paused. And then we'll do an explicit system under test dot. I do not know why I keep doing that, folks. That is just a thing that today seems like it's happening. For whatever reason, tab is on my brain. Advance by milliseconds. 1,000 milliseconds. And after we do all that, the timer should probably only be at 27 seconds, right? So what we're saying is this. We're going to start with our timer at 30 seconds. It's going to start automatically, right? And then we're going to subscribe to it, which means we're going to get values out. We're going to advance by 2 seconds, but because we started automatically, we're going to automatically start getting back values. Okay, so timer is going to be the value. We're going to get that timer, right? And then we're going to say that it should be 28 seconds because we've gone 2 seconds into its execution. So the interval should have kicked. We should be at 28 seconds, which is 2 seconds past that. Right? Then we're going to pause, and we're going to advance it again and show that it does nothing. Even though the scheduler advanced, we are paused. We are paused. So just because the the scheduler is still going, right? Time is still going. I'm paused, so I don't care until you tell me to unpause, and then I'll start paying attention to that thread again, to that scheduler again. Okay? So advance the test scheduler by 2 seconds, and it should still be 28 seconds while it's paused, right? But then we don't have any way to test the resume time, do we? Explicitly. All we can say is that the resume time should, I guess that is a pausing where it resumed, yeah. It's proving that we paused where it resumed because we advanced it by 2,000 seconds. 2,000 milliseconds, that's 5,000 milliseconds just because we have different numbers. So we have some different numbers in here. All right, so that should give us some indication of what's going on. So we'll go ahead and run this real quick, or we'll debug through this real quick and look at this, right? No, we actually don't want to debug through it. Maybe if we can do that, it'll just run through all the way. No, okay. So the start time is 30 seconds. The timer is running, so we're going to go start getting the timer. So we're going to get their value. Come on, worker thread, get out the way. Worker thread. Okay. Yeah, because it's happening on a scheduler, so it has its own thread. So now it's not running. Oh wait, it's still running. Oh, it's running again. It ran and it ticked. So we verified that we are able to advance the scheduler by 5,000 seconds and the value of the timer doesn't change. Then we resume the timer. We advance by 1,000 milliseconds and we show that the timer should still be time span from seconds 27. So it shouldn't have actually started again until we do it. We could technically do an assert here to verify the timer is still 28 seconds, and that would probably be more of a resume where pause, but then we don't actually, well, yeah, we wouldn't take this assert away or take this body of work away because then we can't really prove that it's actually unpaused. But this kind of gives you like a quick rundown of how you can use test scheduling, right? Like, and how test scheduling is valuable. So there are RX operators where this is going to matter even more. You've got like subscribe on, which will take on some scheduler, right? So we can put the scheduler in there, and then you've got observe on, which also will take a scheduler, right? So these two things are important because you can subscribe on a specific thread and box and unbox on that thread, and then observe on a specific thread, which will marshal you back to that thread. And now you can use a test scheduler to test the marshaling of thread context. So I know that today is a little bit of a short stream. I'm not going to dig too much further into this concept today. I'll probably come back and do some more development around test schedulers in the future. Just me kind of writing code and having to test using test schedulers because I do need to formalize these timers that I have right now. But hope you enjoyed it. Hope it was valuable. Again, I know it was short today, but it's been a long week and I could use some downtime. So, again, test schedulers are awesome. Use them. Know when to schedule things on certain threads. Understand threading in context to RX. If you have any questions, find me on Twitter. Find me in the RX UI Slack. We can hopefully get you squared away.